Okay, so we're going to start with 7. So on 7, they give you 2 different studies, and they want you to say what kind of bias it exhibits, and then use evidence. It says a few sentences. If you can do it in one sentence, you can do it in one sentence to explain why you chose that kind of bias. So if we look at part A, says one part of the Nurses' Health Study is concerned with possible causes of skin cancer. Nurses were asked about different behaviors and aspects of their health when they entered the study. Then the nurses were given the questionnaire again if they were diagnosed with cancer. When the questionnaires were analyzed, the investigators discovered that after the nurses were diagnosed with cancer, they tended to report a reduced ability to tan. It is thought that the shift in reporting might be caused by an awareness of their diagnosis. So what kind of bias do y'all think this one would have based on that information?
Like, I know what they're talking about. It's like, that's like, they're like professional and medical.
Yeah.
I guess.
Response bias? Why do you think it's response bias?
Because they only reported that after that they had learned it.
Good. It is response bias for that reason. So,
What makes that response bias?
because they only said they had problems tanning after they learned of their diagnosis. So the fact that they knew their diagnosis, I'm like, oh, you know what? Now that you tell me that, I do know this, I can't tan as much. Before that, they maybe didn't notice it, but then they were made aware of it. Does that make sense? Okay. Let's write it on here. Response bias. And we'll say the awareness of their diagnosis. May have caused them to change their response. Questions on 7A? Okay, let's look at 7B. Which one?
Sure.
Were you saying which one you thought it was?
No, I just saying I got you this time. There you go.
One part of the Demographic and Health Surveys program is concerned with measures of malnutrition. So investigators measure physical aspects of growing children and attempt to document the physical characteristics of a population at different ages. Sadly, in some countries, many children die early, and thus a bias is introduced in the study when the investigators cannot collect the data from the deceased children. What kind of bias do y'all think this one is? Non-response. And why do we say it's non-response?
Some weren't able to respond, so they were able to select the death.
That's right. They can't collect the data if the child was deceased. Okay, so any questions on 7? Okay, now let's go to number 9. That one's kind of small up there. In competitive sports, video recorders have been used more frequently in recent years. The idea behind the recorder is that coaches can replay the training sessions for more effective feedback to the athlete. Some people believe video recording may make the athletes more nervous and actually decrease their performance. You've been asked to design an experiment to address this issue for competitive high school tennis players. You have decided to use the accuracy of tennis serves as your response variable and the number of successful serves out of 100 as your performance measure. The subjects for your experiment are 60 high school male competitive tennis players of varying ability who have volunteered for this experiment. Describe the treatments in your experiment.
When it asks that, is it asking like how you found it or just what the treatments are?
Just what the treatments are. So,
Yeah, we just learned it.
that's right. So we could say that treatment 1 we record the player. And then treatment 2, we don't record the player.
It took all that time trying to explain it. The other test.
Okay, B asks for one possible confounding variable, or it doesn't ask, it tells us. One possible confounding variable is the experience levels of the players. What method would you use to control this variable? Random selection. Okay. But that still could be confounding because random selection means that you could pick all experienced players. I mean, the chance is there that it could happen. So we don't want that to even have a chance of happening.
What's that one thing called the heterogeneous? The cluster?
Cluster
It says something about heterogeneous.
Blocking.
blocking. That's what I'm looking for. What did they say? That's right, David, blocking. So we can block. So you could use blocking.
So on a question like this, we wouldn't have to explain how we do that.
I would like y'all to explain. Yeah. And I'm about to kind of show y'all one way to explain it. I'm just rereading my notes here. So what you could do here is order the players by ability, or experience, I should say. Order players by experience. Take the top two and block. And I'm just summarizing this. Now, if you were writing this formally, I would like y'all to kind of fluff it out some, but I'm just trying to summarize here. Take top two players and block. Take next two and block. And so on until all are blocked.
Like you're saying, like get those first two and put them like separate, or put them both in the same block?
Put them in the same block. So we're going to order the players by experience. And then go through and the first two. The two with the most experience, they'll be a block. Then we'll go to like players 3 and 4 by experience. We'll group them together. And 5 and 6, group them together. 7 and 8 until all of them are blocked.
So like, could you not like separate them like that, where it's like 1, 2, and then 3 and 4? Or is that not?
What?
Is that not blocking?
Repeat that one more time.
Like if it's like, we go 1 in a block, and then 2 in another block, and then 3 in one block, and then 4 in another block.
That's not really blocking by experience.
Alright, I got you.
That's not. What you're actually wanting to do here is within each block, randomly assign treatments.
Okay.
So if you have the top two, chances are they're probably pretty equal in experience. You're going to randomly assign those a treatment. I am running out of room. So when we randomly assign treatments, that means one is recorded, the other is not. And that way, experience isn't a factor, because you're, in each block, you're going to be recording one of them. So you're going to cover all experience levels. Did that kind of help on 9D, Nate? It did. C. Do you feel the results of this experiment can be generalized to all male tennis players? Why or why not? Let me ask you this. Who did they sample? High school male tennis players. Do you think the professionals care if you video them or not? No. They don't even really care about the crowd much. So, could we generalize this to all male tennis players? No. Say no. Competitive tennis players are presumably more used to playing in front of a crowd. And being recorded. Also, what's another big one that another reason we could say we couldn't generalize? It didn't come from the population, but in particular, it was made up of what? In that last sentence? Volunteers. Also, volunteers aren't generally representative of the population. Yeah. Okay. So those are the two that people specifically said I want worked. Are there others that came up and you're like, no, yes.
Maybe 1 through 4.
1 through 4, sure. Yeah, multiple choice was kind of tricky on this review. Okay. So 1, a florist wanted to investigate whether a new powder added to the water of cut flowers helps to keep the flowers fresh longer than just water alone. For a shipment of roses that was delivered to the store, the florist flipped a coin before placing each rose in its individual container with water. If the coin landed heads up, the rose was placed in water with the new powder. Otherwise, the rose was just placed in water alone. Which of the following is the best description of the method used by the forest? Okay, so let's kind of take a poll here before we just run through the answers. How many think it's a census, because all roses were assigned to a container? Okay. B, an experiment with a completely randomized design. Okay. C, an experiment with a block design with blocking by type of water. Okay. D, an experiment with a matched pairs design. Or E, it's observational. Okay. So I didn't see any for E, didn't see any for A, which that's good because E and A are not the answer. But I did start seeing hands for B, C, and D. So let's look through each of these. Wait, you know what? Oh, did anyone say D, match pairs? I don't think anyone did. No, think about it. Okay, no. So it's not D. It's not match pairs. We're not pairing anything up. So we're stuck between B and C here. So let's look at C first. It says an experiment with a block design with blocking by type of water. Is type of water could type of water be considered a confounding variable? No, why not?
It's the treatment.
It's the treatment. We can't block by our treatment. Can't block by treatment. So C is out. That leaves us with B as our answer. So B is the correct answer. Okay. Number 2, which of the following distinguishes an observational study from a randomized experiment? Now, the key on questions like this, when you read the answer choices and they say always used or never used, try to play the devil's advocate. What do I mean by that? Try to think of a way where it's like, think of this example. You used it, so throw it out. If you can think of one example that can do away with the always or the never, then you can throw out an answer choice. So A, in an observational study, volunteers are always used, whereas in a randomized experiment, a random sample is always taken from the population. What do y'all think on A? No. What do y'all say no to A? Volunteers aren't always used. So this piece right here, yeah, that's going to throw A out. Volunteers aren't always used. B, in an observational study, a random sample is always taken from the population, whereas in a randomized experiment, volunteers are always used. Is that true? No, why not? We could actually, again, go down to the end again here and say volunteers are always used in an experiment. No, not always. Throw that out. No, always here throws it out. C, in an observational study, treatments are not randomly assigned, whereas in a randomized experiment, treatments are randomly assigned. What do y'all think on C?
It can still be random on an observational study.
Do we assign treatment to an observational study?
Oh, sorry.
We don't. That C is the answer. Because in an observational study, we do not assign treatments. We just do exactly what the word says. Observe. And then for D, you want someplace to look in your notes for D, look at your that calculus test example. Calc test example. That one, we have no control group. But yet, we said it was an experiment. And then E, an observational study can be double blind. Remember, double blind means the subject and the one who measures does not know what's going on. An observational study can be double blind, whereas a randomized experiment can only be single blind. Because the experimenter determines who is randomly assigned to each treatment. So E is out because let's just think about a simple experiment. You're testing, it's kind of like the one here, I want to say is number 8. Talking about Coke and Pepsi. Let's say you have 2 cups, and you come up to me and I'm like, okay, I want you to taste these cups and say which one you like better. Well, all I've got to do, I'm asking you that question, so you taste it and you're like, okay, I like this cup better. I like the one on the left better. Okay. So, if I don't know what's in the one on the left, they just were given to me by someone, and I put them in front of you. I don't know what's what. I didn't taste them. And you say left, so I write down left. Okay, I give it back. They give me 2 more. I set it down. I'm recording. I don't know what's what. You're tasting. You don't know what's what. We just know what's on the cups. That's double blind, even though it's an experiment. So that's why E is out. Okay, that was number 2. Number 3. Approximately 52% of all recent births were boys. In a simple random sample of 100 recent births, 49 were boys and 51 were girls. The most likely explanation for the difference between the observed results and the expected results, in this case, is what? A says bias. Is there any way to be biased if you're recording boys versus girls births? No. They don't tell us anything that leads us to believe it's biased. Now, if they told you they only sampled from one hospital, okay, then yeah, I can see where bias could come in there. But they don't tell you. So we can't say bias. Variability due to sampling. All that's saying is if you take one sample, that can be different than another sample, which can be different from a third sample. So, maybe. Non-sampling error. It didn't say anyone refused. So throw that out. A sampling frame that is incomplete. Did it say that it left out any hospitals or anything? No, it doesn't tell us that. Confounding variables. Does it tell us there's something in the water that makes it to where one person has a boy rather than a girl? No. So it can't be confounding. We're not going to say, oh, you went to this hospital. That means you're going to have a girl. So it's variability due to sampling. And another way to think of that is if you're sitting there flipping a coin 100 times, how many heads do you expect to get? 50. If I sit here and I stand, if we had the time and I flipped it 100 times, would I get exactly 50 heads?
Most likely.
Most likely not. If I did that experiment again, would I get the same number of heads I got the first time?
Most likely.
Most likely not. That's what B means. And then for number 4, the answer to 4 is stratified. And we're kind of running out of time. But the way to remember this, if you were stuck between stratified and cluster, stratified means you have, let's just say, 3 different populations or 3 different groups. And you just pick a few from each group. Cluster means you have 3 different groups. You randomly pick one group, and then everyone in that group answers. That's the difference between stratified and cluster. If you were stuck between those 2, that's why it's stratified. Did this kind of help with some of the vocabulary that's going over? That's what I would really recommend studying tonight. AP is vocabulary. Make sure you know what's what. How do you find treatments? How do you find what we have? Yes.
Would it be like questions asking us to write paragraph how something is like random, etc.?
How something what?
How something is random, etc.?
They could ask you to, how would you make this experiment random or something? Is there an example, is there one on the notes, on the review like that? Now they could ask you how to randomize something.
Hey, Mr. Schultz, could you assist me real quick?
Sure. Let me stop the recording right quick.
All right, thank you.